Well, now we are moving on to the next topic, resolving forces. And the first question under this topic has been selected from paper 9709/41 for the session May June 25. We are solving the very first question of this paper. The question is, a block of mass 12 kg is being pulled by a rope up a rough plane. The plane is inclined at an angle of 20 degrees above the horizontal. The rope pulling the block is parallel to a line of greatest slope of the plane. The coefficient of friction between the block and the plane is zero point 0.4. The acceleration of the block is 2 meter per second. Find the tension in the rope. So, as the surface is rough, look at this, the plane is rough. So, first of all, we will have to find the normal reaction force. Before that, let's draw a diagram of the scenario of the system. So, this is the system diagram. Now, first of all, we'll have to find the normal reaction force. So, normal reaction force, if we calculate, is R plus, there is no upward force, downward force is nothing but weight, mg cos 20 degree, cos 20 degree, mg cos 20 degree. Hence our R is going to be, mass of the block is 12 kg. So 12 into 10, 12 into 10, and cos 20 degree, 12 into 10 cos 20 degree, cos 20 degree. Hence our normal reaction is going to be 120 cos 20 degree, 120 cos 20 degree. Well, so let us resolve the forces, and for resolving the forces vertically and horizontally, we always apply the concept of the motion law of Newton, second law of Newton, which is driving force minus resistance to motion is equal to mass into acceleration. So let us apply the same concept. So our concept is driving force, it is sliding up. So concept is driving force minus resistance to motion is equal to mass into acceleration. Okay, so driving force is the tension, the rope, actually rope is pulling the box upward, rope is pulling, this is the rope. So the driving force is nothing but the tension in the rope, minus there is a constant frictional force which is mu r. Because the plane is rough, we should not avoid or ignore the frictional force caused by the plane. Then minus weight is the other frictional force or resistance to motion. So weight is mg sine 20 degrees, sine 20 degree, equal to mass of the block is 12 kg, and acceleration is given 2 meter per second. Here it is given acceleration is 2 meter per second. So if we resolve the forces, in the next step, substituting the values, we will get tension minus mu, frictional coefficient is given 4.4. So zero point 0.4, and we have already found the normal reaction force R. R is 120 cos 20 degree, cos 20 degree, minus mass of the block is 12, acceleration due to gravity is 10, and then sine 20 degree, sine 20 degree equal to the right side, and right side is 24, equal to 24. Now if we isolate t as the subject, then t is equal to, or t is equal to 24 plus it is going to be 4, that is 48 cos 20, 48 cos 20 degree, 48 cos 20 minus, sorry, not minus, plus 120 sin 20, 120 sin 20 degree, sin 20 degree. Now using our calculator we will find that, using our calculator we can see that tension acting in the rope is 110 Newton, 110 Newton. So that is our answer to the final part of the solution. Okay, they have told us to find the tension in the rope, which is 110 Newton. So let's see the next question. Next question also belongs to the same paper, that means paper 41 for the session May June 25. And question number 4 has been selected as the next question. Let's see what it says. It says a lorry of mass 18,000 kg is traveling along a straight road. On a horizontal section of the road, the power of the lorry's engine is constant. There is a constant resistance to motion of 1600 Newton. The steady speed which the lorry can maintain with the engine working at power P watt is 30 meter per second. Find the value of P. So it's a very simple actually. If we resolve the forces horizontally, let us show the direction. It is driving force minus resistance to motion. Driving force minus resistance to motion is mass into acceleration. Now let's see what is the driving force here. Driving force is equal to, we know, power over velocity minus frictional force is constant. Look at this, it is written that 1600 Newton is the frictional force, equal to mass into acceleration. As the lorry is traveling at a constant speed, so there is no acceleration at all, that means it's zero. Or P over V, velocity is already given, which is 30 meter per second. So P over 30 is equal to 1600. Hence our power is going to be, P is equal to, let me write just beside that. If we multiply 1600 by 30, it is going to be 48,000. So 48,000 watt is our power for this steady speed. Let's see the next question. Next question says, at an instant when the speed of the lorry is 16 meter per second, its engine is working at a power of 40 kilowatt. Find the acceleration of the lorry at this instant. So at this time, there is acceleration. Our concept is exactly same. The second law of motion and direction is also same. So driving force, our concept is driving force minus resistance to motion is equal to always mass into acceleration. So what is the driving force? Driving force is P over V, power over velocity, minus resistance to motion is also constant. It has been used, we have already used it, 1600. 1600 is equal to mass into acceleration. Okay, mass of the lorry is 18,000. Let us see, mass of the lorry is 18,000, so it is 18,000 alpha, or acceleration 18,000, 18,000 into a. Now the velocity of the lorry is 16, so P over, and power is also given here. Look at this, it is working at a power of 40 kilowatt. 40 kilowatt means 40,000, and velocity is given 16. So if we divide by 16, minus 1600 is equal to 18,000 into acceleration. Okay, we are supposed to find acceleration. So acceleration is going to be, if we divide 4000 by 16, it is going to be, denominator is going to be 18,000 and numerator is, uh, let's divide 4000 by 16, not 4, it is 40,000, sorry. If we divide 40,000 by 60, it is 2500. So 2500 minus 1600, that is 900. 900. So if we divide 9 by 180, it is going to be 0.05 meter per second square. This is exact value. So finally our acceleration is 0.05 meter per second square. Let's see what B says. Question number B says, when the lorry has reached a speed of 20 meter per second, it begins to ascend a section of road inclined at an angle alpha to the horizontal. The engine now works at a power of 120 kilowatt. There is no change in the lorry's speed as it ascends the hill. The constant resistance to motion remains 1600 Newton. Find the value of alpha. So our concept is same. We are not deviating from the same concept. So this is the diagram for this system. So let us write our concept now. The direction is, it is sliding up on an inclined plane. Okay, that means it is moving on an inclined plane. So our concept is driving force minus resistance to motion is equal to mass into acceleration. Okay, or what is our driving force? The same concept as we have been applying, it is power over velocity minus resistance to motion is 1600. That means frictional force is 1600. But one more force is causing resistance to motion, which is weight. We cannot avoid weight, which is mg sine alpha is equal to mass into acceleration. Mass into acceleration is 0. Now you may ask a question, how can it be, how can there be no acceleration? Look, it is it is written there is no change in the lorry speed as it ascends the hill. That means there it is always at constant speed, means there is no acceleration. Now if we substitute the values, our power is given 120 kilowatt. So 120,000 over velocity is to be obtained. Sorry, velocity is also given. Velocity is 20 meter per second. So 20 meter per second minus 1600, and mass of the lorry is 18,000, and acceleration due to gravity is 10, so it is 180,000. 180,000 sine alpha. Sine alpha is already given here. No, sine alpha is not given, so we will leave it unchanged. Sine alpha is equal to 0. Or if we isolate this 180,000 sine alpha is equal to, now 1600, it is, sorry, in front of this there is a negative symbol. Then if we divide this 12,000 by 20, let one of the zeros be dissolved, so 600. So 600 minus 1600, that is 1000. So it is going to be negative 1000. Well, then our alpha is going to be, or it is not 1000. So from 120,000, if we divide, it is going to be 6,000. From 6,000, if we subtract 1600, it is going to be 4400. Okay, Hence, our acceleration, alpha is going to be sine inverse of. So, if both of the zeros are dissolved, it is going to be 44 over 800. 800 is equal to. So, using our calculator, we find that angle is sine inverse of 44 over 1800 equal to 1.40 degree. So that is what the final answer to this one. That means the angle is 1.40 degree. Well, then let's move on to the next question. The next question has been selected from paper 9709/42 for the session May June 25. And question number one, the first question belongs to forces. So let us solve this one. The question says a crate is being pushed in a straight line along a horizontal surface by a force of magnitude 25 Newton. Inclined at 20 degree above the horizontal, the crate moves a distance of 12 meter in 8 seconds with constant speed. Find the constant speed of the crate. So let us draw a diagram of the system. The diagram may look, this is the horizontal surface. So this can be the diagram of the system. Then they have told us to find the velocity, speed. So we know velocity is equal to distance over time. Distance over distance divided by time. So what is the distance? Distance is 12 meter. Distance over time taken. Time taken equal to distance is 12 meter and it took 8 minutes. Okay, so equal to 12 meter over 8 seconds, sorry, not minutes, 8 seconds. So our velocity is equal to, velocity is 1.5 meter per second. Let's see the next question. The next question says find the work done by the 25 Newton force. Here there is a little twist. So let us solve this one first. Work done by, work done, work done. We know the formula is work done is equal to force into displacement, or force into distance. Okay, force into distance. Now the twist is you may get confused that the force is given 25 Newton, but the twist is, look, they told that force is acting 20 degree above the horizontal. Look at this. It is force of magnitude 25 Newton is inclined at 20 degree above the horizontal. So it is not 25 degree. It is 25 cos 20 degree. So this is the twist. Please don't get confused with this. So force is not 25. It is actually, because 25 means if it is horizontal. Suppose if it is written that horizontal magnitude is 25, then you can suppose that it is horizontal axis. Okay, or that is force, horizontal force. But they have told it is 25 Newton inclined at 20 degrees. So the force is 25. So for horizontal, if we calculate horizontally, it is 25. This one. So this one is 25 cos 20 degree. I think you got my point. Into distance is 12 meter. So finally, the work done by the force is 25 cos 20 into 12 is 281, 281.9 90779. If we round it up to three significant figures, it may be 282 joule. 282 joule is the work done by this force. Then the next question says, find the power at which 25 Newton force is working. So power is equal to, we know the third concept, power formula. Power is equal to work done divided by time taken. So it is work done over time taken. Already we have found that work done by this power was, by this force was what? 281.90, 281.90779 over time taken. How much, how many seconds were taken? 8 seconds. So our power is going to be, if we use our calculator, it is going to be 35.2, 35.2 Newton, 35.2 watts. Okay, so this is what the answer to all of these question, all of the parts of this question, and it's very simple, the fundamental concept of kinematics. Let's see the next question. The next question has been selected from paper 9709/43 for the session May June 25, and we are going to solve question number 4. Let's see what it says. Three blocks P, Q, and R of masses 25 kg, 20 kg, and m kg respectively are held in equilibrium by three light inextensible strings OP, OQ, and OR. The strings OP and OR both pass over small fixed smooth pulleys A and B respectively, with P and R hanging vertically below the pulleys. The block Q hangs vertically below the point O. The angle between OA and the vertical is 30 degree, and the angle BOQ is equal to A degree. Find the value of M and the value of alpha. Look, this is the most challenging question of this paper. So we should be very careful while solving this question. Before the solution, let me complete the diagram. Okay, this is the completion of the diagram. So as I have already mentioned that this is the most complicated and challenging question of this paper. So in this case, first of all, as there are three strings, so which one, or three blocks, which one should be our standard, I mean parameter? First we will start with this one. Okay, and this is driving force for this horizontally, and this is the left onward is our negative force or frictional force or whatever you tell, and this is the upward force as well as this is downward force. So Q is, we will start our solution using Q, which seems to be easier. So let us write for Q. Let us resolve the forces first horizontally. Okay, so for horizontally, what is the driving force? This is positive direction of x, so we will write mr, that means this one should be calculated. So mr cos, mr sin alpha, mr sin alpha, don't get confused. If you are confused, let me clarify this. Look at this, we are calculating this. Okay, horizontally we are resolving the force. So for this one, what is this force? This is actually tension in this string through which R is hanging. So this tension is what? This is mr, and all this tension is how much here? Tension is actually this one. The this one is causing the tension, that is the tension force is on r is this. Okay, at o that positive force is only this one. So mrg sine alpha. Okay, now why is it sine alpha? Because look at this, if we calculate this horizon in term of this triangle, this is vertical line. Okay, that's why sine alpha. Okay, now now negative force. So negative force is this force, which is mg, mass of particle p, acceleration due to gravity, and that is not sine, it will be cos 60 degree. Cos 60 degree is equal to 0, equal to 0, because the system is in equilibrium. Okay, so look at this. First we have calculated this direction. This direction is actually the tension. How much is the tension? Tension is actually nothing but the weight. So driving force is actually this tension along this string. Okay, tension force in this string, and this string is how much? It's actually mg, that means weight of r. So weight of r is mp, mass of particle p, into acceleration due to gravity cos 60 degree. I think you got my point. The driving force is to this direction of q, and resistance to motion of q is to negative direction. So for negative direction it is mpg cos 60, but for positive direction it is actually nothing but the weight. Okay, weight of box or block r. Then if we calculate this, mass of particle r is m, so acceleration due to gravity is 10, so 10 m sine alpha, mass of particle p is 25 kg, so 25 into acceleration due to gravity is 10, and cos 60 is 0.5 equal to 0. If we isolate that value, it is going to be 10 m sine alpha is equal to 250. Half of 250 is 125. If we isolate sine alpha, hence sine alpha is equal to 125 over 10m, over 10m. We may leave this as equation number 1. There will be two simultaneous equations because we are supposed to find two values. So let us resolve the forces vertically. Okay, if we resolve the forces vertically applying the same concept, driving force minus resistance to motion is equal to, I think it's better I can change the color. If we resolve the forces vertically, so upward force is our driving force and downward force is our resistance force. Well, now let's see what is our upward force. Upward force is this one. Okay, as o is our center, so this is upward force. So for this upward force, what is this? The tension is actually weight of particle r, so it is going to be mp, sorry, it is actually lying below. Let me tell this. This is actually our reference frame is this is our reference frame. Okay, as this is our reference frame, so the first triangle is lying below the reference. Okay, this is our, suppose this is horizontal axis, so the first triangle having alpha angle, it is lying below the horizontal axis. So which one is positive? This one is positive. Okay, so for positive, what is our driving force? That is this tension, which is mpg sine mp, mass of particle p into g, and sine 60 degree, sine 60 degree. then minus which angle is lying below the x-axis? This angle is lying below x-axis. Okay, so which is, how will we calculate this? Here tension is mrg cos alpha, mrg cos alpha, mr mass of particle r g, then cos alpha. Okay, and we are not ignoring the weight of q also. Look at this weight of q, that is also a downward force, which is m q sine 90 degree, m q g sine 90 degree, sine 90 degree. I think you got my point. Sine 90 degree, sine 90 degree is equal to 0 because the system is in equilibrium, equal to 0. Okay, so this is what the vertical forces. Once again I am repeating this because you may get confused. So the first triangle, I mean if you talk about this triangle, this triangle is lying under the x-axis, whereas this triangle is lying above x-axis because our o is here. Okay, o is lying over here, so our x-axis is this, x-axis is the reference. So below the first triangle, I mean right side triangle, is acting downward, pulling the, that means the force is acting downward. These two, both of these are acting downward. Okay, these two objects or blocks, only the final one is acting upward because it is lying above x-axis. So q and r, these two blocks are acting downward, the force is acting downward, but p is, due to this pulley, though it is lying or hanging below, but according to this triangle or reference frame, it is actually acting upward. Okay, it is because it is the triangle lies above x-axis. So this is the positive value or driving force in terms of this scenario. Or if we substitute the values, it will show us, so mass of particle P is 25, 25. Acceleration due to gravity is 10, and sine 60 is square root over 3 over 2. Well, square root over 3 over 2. Minus mass of particle R or block R is mkg, and acceleration due to gravity is 10. So 10 cos alpha, 10 cos alpha, minus mass of particle q, I mean mass of block q is 20 kg. So it is 20 into acceleration due to gravity is 10, and sine 90 is 1. So it is 0. Now if we isolate our cos, it is going to be, let me see, can I write? No, there is no space to write at all. If we isolate 10m cos alpha, it is going to be, so 125 root over 3. So let us write 10m cos alpha is equal to, so it is 125 root over 3, 125 root over 3, 125 square root over 3 minus 20 into 10, that is 200, root over 3 minus 200 minus 200. Now if we isolate cos alpha, hence cos alpha is equal to, cos alpha is equal to, numerator is going to be 125 minus 125 root over 3 root over 3 minus 200 over, it will be divided by 10m. 10m. So this is our equation number 2. Okay. So already we have formed both of the equations. Now it's time to solve them simultaneously. Let me write just beside this over here. So what is our first equation? Let us write equation 1 divided by equation 2. So if we divide our equation 1 is sine alpha over cos alpha is equal to, then the right side is going to be 125 over 10m. 125 over 10m. 10m is the first equation. Then the second equation is 125 square root over 3 minus 200 over 10m, or or sin alpha over cos alpha is equal to actually tan alpha. So tan alpha is equal to 10m and 10m, they can cancel each other. So it is 125 over 125 square root over 3 minus 200. 3 minus 200. Or our alpha is equal to, tan inverse of 125 over 125 root over 3, 125 root over 3 minus 200. Hence our alpha is going to be, using our calculator, we find that tan inverse of 125 over 125 square root over 3 minus 200 is equal to 82 point 82.4776. Okay, 82 point 82.477 and 6. If we round it up to three significant figures, our alpha is going to be 82.5 degree. This is our the value of the angle. Okay, angle alpha. Well, then the next value is m. So any of the equation can be picked up. If we pick up this equation, let us pick up this equation. The first equation was 125 over sine alpha is equal to 125 over 10m. That means, hence 10m is equal to, here we can write here, hence 10m, or m is equal to, sorry, m is equal to, our numerator is 125, denominator is 10 into sine alpha, 10 sine alpha. Sine, how much is your alpha? Alpha is 82.477. 82.477. Hence we get our mass of block R is 125 over 10 sine 82.4776 equal to 12.6. If we round it up to three significant figures, it is 12.6. That is what our final answer. So initially I have told that this is the most challenging question in this paper. There are many different views may arise, or different concepts may arise in your mind, but remember, simply I have thought that Q is lying in the middle. So the for horizontal forces, that is right side of Q is driving force and left side of Q is frictional force, I mean resistance to motion, resistance force. And while we resolve the forces vertically, then upward is the left triangle is lying upward, that's why that is a driving force. And the rest two blocks, they are lying below the x-axis, that's why they are resistance force or negative force. Then resolving in this way, it can be, I think this is the simplified form of this complicated question. Let's see the next question of this paper. The next question has also been selected from the same paper, I mean 9709 slash 42 for the session, 43 for the session May June 25, and it is question number 6. It says the diagram shows the vertical cross section ABC of a rough water slide. This is a rough surface. The section AB is a straight line of length 5 meter inclined to an angle of theta to the horizontal where sin theta is zero point 0.8. The point B is 2.5 meter above the level of sea. A man of mass 80 kg modeled as a particle slides down the water slide. Starting from rest at A, the coefficient of friction between the man and the straight section of the water slide is zero point 0.1. Find the speed of the man at B. So directly we cannot find the speed here. There will be two steps. First we will find acceleration, okay, and for acceleration we always apply the concept of the motion law of Newton. Before that, we will have to find out the components of this law, as the plane is rough. Okay, so first of all we'll have to find our normal reaction force. Before that, one more thing is given here about the angle is not given. They have written sin theta is equal to zero point 0.8. So if it is, this is theta, zero point 0.8, zero point 0.8 means sin theta is zero point 0.8. That means this is perpendicular line is 8, hypotenuse will be 10. So surely our horizontal or adjacent line is going to be 6, because 6 square plus 8 square means 10 square. Well, then we will have to complete the diagram. Suppose here, okay. So this is the system. So let's find our normal reaction force. If sin theta, before that let us write normal reaction force is R plus, there is no upward force, so it is 0, and downward force is mg, I mean mass, I mean weight, mg cos theta. Okay, now hence our R is going to be, mass of the particle is 80 kg, that means mass of the person is 80 kg, acceleration due to gravity is 10, and cos theta. Okay, cos theta is 6 over 10, that means 0.6. So we have got our normal reaction force is 80 into zero point 0.6, that is 480. That is 800 into, so 480 Newton is our normal reaction force. And we are going to apply the concept of motion law of Newton, which is driving force minus, as the first direction is this, he is sliding down, so driving force minus resistance to motion is mass into acceleration. We should not forget that we require acceleration to know the velocity. So driving force is here, only weight is causing the person sliding down, so mg sin theta. Driving force is mg sine theta, and frictional force is mu r. Mu r, and mass of the person is 80, acceleration is to be obtained. After that, if we substitute the value, mass of the person is 80 into acceleration due to gravity is 10, and sin theta is equal to zero point 0.8. Already we have used 0.8, minus mu frictional coefficient is zero point 0.1. So 0.1, and we have just got that our normal reaction is 480 Newton. 480 Newton is our normal reaction. So let us multiply by 480. 480 equal to 80 into acceleration. Okay. Now if we isolate our a, it is going to be 80 will be denominator, and here from 808 it's 640. So from 640, if we subtract 48, it is going to be, let us write 640 minus 48. Hence our acceleration is going to be, it is an exact figure, 7.4. 7.4 meter per second square is our acceleration. So applying the concept of kinematics, we can find that hence v square is equal to u square plus 2as. Okay, or v is equal to square root over u square. The person started sliding from rest, so it is going to be 0 plus 2, and acceleration has been 7.4, and s is the displacement is 2.5. The displacement is 5 meters, sorry. Look at this, let me show you. The distance from A to B is actually 5 meters. Okay, so the value of S is 5. Let us write here 5. Hence our velocity is going to be square root over, that is 2 into 0.74 into 5, that is 8.60 meter per second. So our velocity at point B is 8.60 meter per second. That's all about this question. Then let's move on to question number 40 from paper 45. Let us solve the final question of this session. The next question has been selected from paper 9709/45 for the session May June 25, and we are going to solve question number 4 under this concept. Coplanar forces of magnitude 17 Newton, 51 Newton, and 34 Newton act at a point O in the directions shown in the diagram, where tan alpha is 15 over 8. Find the magnitude and direction of the resultant of the three forces. So we'll have to find the resultant force. And before we start our solution, let us complete the diagram. Yes, this is the diagram of the system, and they have given tan alpha is 15 over 8. So tan alpha is 15 over 8 means this is the triangle where alpha, so tan alpha is 15 over 8. That means the vertical line is 15 and horizontal line is of 8 units. So what will be our hypotenuse is going to be square root over 15 square minus 8 square, that is 17 square. So it is 17. 15 square plus 8 square equal to 17 square. So our sine theta is going to be, one more triangle is required to be done. Okay, sine alpha. Sine alpha is going to be perpendicular line over hypotenuse, that is 15 over 17, and cos alpha is going to be adjacent line over 8 over 17 hypotenuse. Then one more triangle is left to be drawn. This is the final triangle which I didn't draw first. Yes, this is the final triangle. So there are three triangles. Now we are going to resolve the forces horizontally. Let us write. If we resolve the forces horizontally, so resultant force in x direction, okay, equal is not equal to. So now look at this. The positive side of x direction is the first triangle. Upper triangle is 51 cos alpha. 51 cos alpha, one of the triangles. Then the just below that, the second triangle is also in the positive direction of x from O. So that is also positive, which is 34 cos alpha. 34 cos alpha. Then in the negative direction there is another triangle, which is the third one, negative 17 cos 90 degree minus alpha, because look at this, total is 180. Okay, if the center, if this is 90, so the remaining angle will be 90 minus alpha. 90 minus alpha. 90 minus alpha. Well, then if we simplify more, it will be, let us simplify, or 51 cos alpha, 51 plus 34, it is actually 85. So let us write 85 cos alpha, cos alpha, the 85 cos alpha minus 17 cos 90 minus alpha is actually sine alpha. 17 sine alpha, sine alpha. Then let us substitute the values. Already we have obtained the value of cos alpha. Value of cos alpha is 8 over 17. 8 over 17. And sine alpha, value of sine alpha is 15 over 17. 15 over 17. So if we finally simplify this, this is 5 at 40. 40 minus 15, that is 25 Newton. So horizontal resultant force is 25 Newton. Now we are going to resolve the forces vertically. So let me write resolving forces vertically. Resultant force in vertical direction. So look at this, only one triangle is lying above x-axis, so that is positive, which is 51 sine alpha, only the upper triangle 51 sine alpha, and the remaining triangle lying below x-axis, they are negative, so minus 34 sine alpha, minus the other one is 17 sine 90 minus alpha, 90 minus alpha. Okay, then 51 sine alpha minus 34 sine alpha, if we subtract, this is going to be 17 sine alpha. 17 sine alpha, 17 sine alpha minus 17 sine 90 minus alpha is actually cos alpha. 17 cos alpha. So it is going to be finally equal to 17 sine alpha stands for how much? Sine alpha is 15 over 17. 15 over 17. I think I should write just below that. So sine alpha is equal to 17. We have already obtained sine alpha is 15 over 17. 15 over 17 minus cos alpha 17 into cos alpha, which is cos alpha is 8 over 17. 8 over 17. So finally our resultant force in y direction is going to be what? 15 minus 8, that is 7 newton. 7 newton. 7 newton is our vertical resultant force. So horizontally we have got for 25 newton and vertically we have got 7 newton. Then they have told us to find actually the magnitude and direction. So magnitude, for magnitude, look at this. If it is our, let me show you through this, x and y, x direction and y direction, both of them are positive. Look at this. For x direction it is positive 25 newton and for y direction that is 7 newton. So both of them are positive. That means our magnitude of force is over here. The point will be over here. Okay. So horizontal magnitude is 25. Okay. Horizontal resultant force is 25 and vertical is 7. So this is actually our magnitude. Okay. Let us find the magnitude of this hypotenuse. So magnitude is equal to magnitude is equal to, we know, to find the hypotenuse we just sum up the squares. So 25 square plus 7 squared, 7 squared. So it is going to be 25 square plus 7 square, that is if we round it up to three significant figures, it is going to be 26 newton. 26 newton. So our resultant force is 26 newton. Now direction has already been we have already decided that that is on the first quadrant above positive x-axis. But how much is the measure, how much is the quantity? So for that, let me take another ink. Okay, so direction is equal to, for a direction there is no necessity of writing in words, as I do have less space to write. So simply we look at this, vertical side and horizontal side are given, so we can use tan theta. Tan theta is equal to, vertical distance is 7 and horizontal distance is 25 units. So our theta is going to be, hence our theta is going to be tan inverse of 7 over 25. 7 over 25. Hence our angle is going to be tan inverse of, equal to, using our calculator we will find tan inverse of 7 over 25 means 15.6 degree. It is 15.6 degree. And the direction is, so how will we write direction? Then if we sum up, it can be written that 26 newton force is acting at 15.6 degree above positive x-axis. So let me write this. So if we sum up the answer, we will write 26 newton force acts at 15.6 degree above positive x-axis. X-axis. So our magnitude is, individual magnitude is 26 newton and our angle, I mean direction, is 15.6 degree above positive x-axis. So that's all about this topic. Let's move on to the next topic.